In this video, I would like to explain the idea of the cosine and sine laws. These are very important laws that appear in trigonometry and geometry. So the idea behind this is that if you draw the following triangle, we know that every triangle can be identified by their three angles. So let's call this first angle alpha, the second angle beta, and the third angle is gamma. Of course, the sum of the three angles inside the triangle is 180 degree. And also, a triangle is defined by the three sides, the length of the three sides. So let's call the side opposite to the angle alpha by side A, and the side opposite to the angle beta, let's call it side B, and the side opposite to angle gamma is side C. Now, is there a way to relate the angles, the three angles, okay, alpha, beta, gamma, alpha, beta, and gamma to the sides A, B, and C. Okay, so the first law that is famous called the sine law. So how do we find this law? So the first thing we need to do is to connect the vertex of this triangle to the base. So let's actually drop this side from the vertex of the triangle, the top vertex, to the base of the triangle. All right, so in this case we will have two triangles now, kind of two triangles connected together, okay, as you can see. And let's call this, define this by h. Now this side h is basically the definition of the height of the triangle. So as you can see, the height is shared by triangle 1, T1, and the triangle T2. So how can we find the sine law? So since this h, so the height of the triangle T1 is equal to the height of the triangle T2, because they have the same height and they're shared together, connected together. So according to the sine law, we know that sine of any angle, sine x, is defined as the length of the opposite side to angle x divided by the length of the adjacent. Okay, and this only defined for a right angle triangle. So as we said, the vertex, when it's dropped onto the base, vertically, that forms the angle 90 degree. Okay, so this triangle is basically T1 is a right triangle, and also T2 is a right triangle. So now we can use these, for right triangles, we can use the sine definition, which is the length of the opposite side to x, divide the length of the adjacent, which is basically c. So according to this, we can write sine the angle beta here equal to the length of the opposite side, which is h, divided by the length of the adjacent, which is capital C. So from here, if you do cross multiplication, you will get that the height can be written as the side length C, the adjacent, multiplied by the sine angle of beta. So this is actually HT1, right? So this is HT1. Similarly, if you try to find sine of the gamma, you will get H divided by B. So H is the opposite side, divided by the adjacent, which is capital B. Now do the cross multiplication. You will get that HT2 is given by B times sine gamma. So because HT1 is equal to HT2, right? So we can equate this to be sine beta, angle beta, equal to B times sine angle gamma. Now by dividing the first side by sine gamma, okay, so basically what we can do is we can divide the equation by sine gamma, and divide the equation by sine beta. So you can interchange them here, and what you get is C divided by sine gamma equal to B divided by sine beta. Okay, so it's very clear that the side, so this basically is actually part of the sine law, so which basically relate two sides C and B, the two angles gamma and beta. So what we can do now is we can actually do the same thing, same analysis between two angles gamma and alpha with another height defined for the triangle, and you will get the same thing, and you can relate gamma and alpha together to the same way as we did before. So this will be equal to A divided by sine alpha. So if you do the same analysis, and that's basically what we call the sine law. Okay, so this is basically the sine law. And what you can, in words, that each side of the triangle divided by the sine of the angle opposite to that side, always equal to the other side length divided by the sine of the angle opposite to that side, and so on. Now, what about the cosine law? So the cosine law, okay, is a bit different. So from its name, we need to find or relate the side length and to the cosine of the angle of the triangle. So again, if we take the side okay, let's now again break this triangle into two right triangles. All right, and remember, let's keep this the same. So this is angle beta, this is angle alpha, and this is angle gamma. Side C, side A, and side B. So let's first start with defining the cosine. We know that cosine of any angle x in the right triangle is defined as the ratio of the length of side adjacent to x divided by the length of the hypotenuse Okay, so of the triangle. And in this case, let's consider cosine beta. And according to this definition, it will be the ratio of the height h, okay, this side, so the adjacent. We're talking about this side, this is the adjacent. Okay, we'll just call this B1. So it's B1, the adjacent, h is the opposite, divided by the hypotenuse side, basically, which is given by C. So now we can rewrite B1, which is basically the length of the base of the triangle, to be C cosine beta. Now, how can I relate B1 to the sides A and B capital? So now, what we can do is that we know that A capital, which is the base of the big triangle, can be written as, if you call this B2, this side, from here to here, so we can call A equal to B1 plus B2. Okay? Now what we know that B1, we have that, sorry, we have that C square is equal to h square plus B1 square. This is according to Pythagoras theorem. All right, and also from the other triangle we have that, which is also a right triangle, and for the second triangle we have that, using Pythagoras theorem, we have that B square equal to h square plus B2 square. Now we have two equations, so if we subtract the two equations from each other, we can have the following relationship: c square minus b square on the left hand side of the equation equal to h square minus h square cancels out, equal to b1 square minus b2 square. Now using this formula, we know that b2 can be written as a minus b1. So b2 square equal to a minus b1 square. And if we defactor it, this will be a square plus b1 square minus 2a capital B1. So if you substitute this here, and of course we see that B1 is actually written in terms of the parameters of the triangle as c times cosine beta. So this will be a square plus b1 square, which is c square cosine square beta, or of course let's just keep it as is for now, and this will be b1 square because it will cancel out later, so times minus 2 times a times b1, which is c capital cosine beta. So substituting this b2 in this equation, we will get c square minus b square equal to b1 square minus the whole thing here, so minus minus times a squared is minus a squared, minus times b1 squared is minus b1 squared, and minus times minus is positive, plus 2a c cosine beta. Now we can see clearly that this term will cancel out with that term, and now we can see that if we rearrange these terms, if we transfer this to the other side and we get these two terms to the other side, what you get is b squared equal to a squared plus c squared minus 2 times a times c cosine beta. And this is called the cosine law. So as you can see, we were able to relate the sides A, B, and C to the angle beta. So it's very clear that this formula to find the side of one of the triangle, knowing the other two sides, and the angle opposite to the side B can be related with this formula, which is called the cosine law. So similarly, we can find, or we can relate, the side of the triangle, which is A, by the same formula. A squared is equal to B squared plus C squared. So now here you use the other two sides, minus 2 times B times C times cosine the angle opposite to A, which is alpha, cosine alpha. The third equation is that we have C squared, the side of the triangle squared, C, equal to A squared, the square of the sides of the other two sides, plus B squared minus 2 times A times B times cosine the angle opposite to C, which is gamma. So this is 1, this is 2, and this is 3. That's it.